Good afternoon. How's everybody doing? The transformations go okay? The transformations, the slides, the shifts. I hope that you enjoyed them. Today we're going to continue on our transformation. Last time we talked about what happens if you add and subtract. Oh, yes, Mia? Select all that apply. I'm not sure about what.
No, they were like
Oh, it had stretches and compressions. Oh, okay.
Reflections of value.
We did not do that. Definitely, yeah. Last time all we did was the moving, right? So that was on homework. That's annoying. I'm sorry about that.
Like it was just there.
Oh, I see. Oh, okay. Oh, so it's one of the answer choices, but you already knew which one to go to, but you're so it's kind of a foreshadowing of what's to come then. That's interesting that they put that there. It seems a little early. But that's okay, just a couple days early, because that's what we're doing today. So today we're talking about graphing functions using horizontal and vertical stretch / compression. So I have gestures for these things. I love using gestures anytime I can in math. A stretch, you grab it and pull it apart. That's called the horizontal stretch. I think you can match with a vertical stretch looks like. You grab it, pull it apart, as opposed to a compression, like horizontal compression, where you take the sides and push it together. Vertical compression. So that's what we're going to do. How do we get there? It's not with addition and subtraction. It's going to be with division and multiplication. So let's see how these are going to work. So here we have a function. You recognize this function?
Yeah.
Is this the function you have to memorize?
No.
No, definitely not. You have to know the other functions, but not this one. Those the library functions. Maybe we'll talk about that next time a little bit. Like a little review. Okay, so in this case, we're doing it different. What's that?
We don't have
No, but it's I'm not sorry. Okay, so we're gonna graph make a graph based on that. So notice it's 3 times f of x. Now normally see f of x is a y value. So each one of these y values, if we're gonna move up 3, it's going to be stretched by
3 times.
a factor of 3, is what we say. So when I do that vertical stretch, that's what this is. Right in the middle of that vertical stretch is what?
0.
Specifically the x axis, right? Right in the middle of the stretch. So let's just take the points and move stretch them so that it's the y values are stretched by a factor of 3. Oh, let's dot in the original function first. I'm going to ask you to do that anytime you're doing these transformations. Oops, yes.
I can practice it the first
Sure, yeah, next time just let me know before class, please. Thank you. Even just shoot me an email telling me what's going on. Thank you. Okay, so that first point at -4, -1 is going to become -4, -3 because we stretched it. -2, 2 is going to become -2, 6. I'll let you finish. What's going to happen to that last one? 4, 0. This is a vertical stretch. The y values are being multiplied by a factor of 3, which results in a vertical stretch. So we have this to this to this to this. Okay. Looking at the original compared to this, you see the vertical stretch. Okay, so we have f of x equals x squared. We know what that looks like. The parabola. Do you have your pocket parabolas? Do you bring your pocket parabolas? Well, it's here. No? No? Did you bring it? Okay, good. Yeah, so we have a pocket parabola. So that's 2. We're gonna take our pocket parabola and stretch it. Remember, my x-axis is over here. There's nothing in the bottom. I can't go ahead. So y value we're gonna divide to for the first one. So maybe we're gonna use different colors. If you have colored pencils or something, since we're gonna have 3 different graphs here. If you don't have it, that's fine. And I'll label this f of x, or y equals f of x. So 2x squared, what's gonna happen to that vertex? Gonna stay right where it is. That point 1, comma 1 is gonna go 1, comma 2. Same thing on left and right. 2, comma 4. 2, comma 8. Same thing left and right. We'll call that one y equals g of x. Go into the third one, or the h of x equals 1/2 x squared. But all those y values are going to be halved, which means our parabola is going to be squashed. Yeah, it's gonna be wider, isn't it? It's squashed. Like 0, 0. I'll do this one in red. 0, 0 becomes 0, 0. 1, 1 becomes
1.5.
yeah, 1 and 0.5. Those x values aren't changing at all. It's just the y values. 2, 4 becomes 2, 2. Well, it used to be 3, 9. It's now 3, 4.5. I hope this is comfortable for you. How would you say the y value? 4. But do any more points fit on it? Yeah, it was 4, comma 16. Now 4, comma 8 will fit. And negative 4, comma 8. And I'll label this y equals h of x. Yes. Thank you. Okay, this is a whole lot of words. Really, notice we're dealing with multiplication. And that multiplication is happening. How do we explain the placement of this outside of the inverted result, we put a vertical difference. Before it was like moving up and down. Now it's a vertical stretch. But it's only a stretch if A is not big. Greater than one. Definitely not zero. If you need zero, it's all over. If it's greater than one, it's a stretch. If it's I mean, between zero and one, then it results in a vertical inversion. That's all this is.
But it's so every hypothetically negative.
Oh, yeah. So, but it's just like kind of great.
Right, but not with that.
That's another way. But I'll tell you, all the way that is positive.
Oh, it's ripped away.
Yeah. Nice. Okay, so I'll leave it there.
Oh, would you label
Oh, here I labeled this stuff. Sure. You're good? Okay, hey, we have the same function again. I wonder what's gonna happen to this one. In this case, it's not asking for f of 2 of x. Now notice that placement of 2, it is inside the function. When it's inside, please remember that the transformations are counterintuitive. You might think it's going to be a stretch by a factor of 2, but it's not. It's a smush or a compression by a factor of. What do you think? 1 over 1/2. Yeah. But we say factored, like we're multiplying it by, and then the compression is the with like the physical description. I see what you're saying though. But in general, compressed by a factor of 1/2. So like that first point, -4 comma -1 becomes -2 comma -1. Oh, I have to dot it in. Let's dot these. Or you want to do it without dotting, you just want to keep it from the original? I'm going to dot mine, but if you just want to go for it and reference the original, that's fine. There's a -4 comma -1 becomes 2 comma -1. -2, 2 becomes -1, 2, right? It's just the x value that's being cut in half. 0 comma -2 becomes 0 -2. 2 1 becomes 1 1. 4 0 becomes 2 0. Oh, did I mess up? I messed up. Thank you. The danger of doing that dots in the wrong place. Good catch. I appreciate that. So 1 1 becomes 1/2 1. 1/2 comma 1. Thank you for catching me there. Does it look smushed? With that the y-axis in the middle, it looks like that, doesn't it? He can say smushed, but really I'm always going to say, does it look like it's been compressed by factor of 1/2? Let's just make sure that it really works. Let's see what happens if you plug in a -2. If you comes out of -4, you know what that's -4 is? No. So it's like here, right? -4 is and so when we plug it into this function to the back and output is this time. Let's just check one more to be sure. What else do we plug in? I don't think we plug in 6. Nothing there. Let's plug in 1. What should come up? Oh, this is going to be a little strange to me. We don't have points there. Let's plug in one of the points that we have. 0. Let's plug in 0. If everything was valid, we can do it again. Plug in 0, 2 times 0 is 0. We're not asking 0 is. Then I think we have to do it. It's not if it's correct. way. You notice in the second graph, again, that 1/2 is on the inside, but in this case, the number is between 0 and 1. What's going to happen to our function? It's going to be stretched by a horizontal by a factor of 2. So I'm going to very carefully dash in these the original function 1, 1. Okay. I'm gonna call on someone to give me all the coordinates of our function in B. Or the universal constant, I should say. And make sure you're checked with the neighbor once you're done. Okay. I need some help. I just want to know the new coordinates. Priscilla, can you tell me the new coordinates, please? -0. How do you get -0? Just out of curiosity. Okay. So -8 comma
Oh, negative.
-1. Okay. And the next one, I want all of them. Do we agree with that? Therefore, 2. Yeah. Okay. Okay. 1, 2. So up here, like that. Give me 1, 2, or 2, 1. You need 2. 0, 8. Is that what you want to say? 8, 0. You're just checking to see if I'm paying attention. I like it. Did I pass? Thank you. Okay, so I connect the dots. It looks something like this. Oops. You see the stretch? Now, if it would have been 1/3 x on the inside, stretched by 3. If it would have been 2/3 on the inside, stretched by 3/2. Nice. So we're dealing with, what's the word? Reciprocals. And let's just check just to make sure, just for peace of mind, because otherwise might be kept up at night. But that's the right way. Right, that kind of keep you up at night. And something that, I mean, I'm struggling with this problem all night. I'm just not sure. Let's plug in. I don't know. We should plug in. -3. Would that be good to plug in? Sure. You don't know that. Let's plug in a -2. I don't know that. It kind of looks like putting on the point that I'm about.
How long are you making?
-4. Let's do that. Output should be.
Negative.
Output should be 2 if I get it correctly, right? Okay, so you plug in -4. 1/2 of -4 is. -2. Do you know what -2 is?
Yeah.
It's good. Yeah, it works. With reference to our original function. Remember, when it's inside, it is counterintuitive. If you can remember that, you'll be fine. Oh, let's try an example. Oh, here's the synopsis. There's a huge error in here. Huge. No. You find the error. You know, you're thinking deeply about this one. I'm looking for the error. Do you see it? Yeah, I don't know if that replaces X with A. That's weird. So I'm gonna erase that, but there's something that's just wrong. Should be a factor of 1/A for both of these. 1/A. Put a little hat on that A
Why on the first?
because, yeah, because
Well, not here. Remember we had the 1/2 here? 1/1/2. No, on the bottom, right? You know, like 5. Yeah, you know, right, depending on what you did. Yeah, exactly. Divided by, not 5, factor of 1/5. But then you're stretching. Oh. Yeah, so it's said, I like it's always worded, it's said. It's remember, what's on the inside is opposite of what you think, which is greater than 1. Not exception, is a confession. These are 1, it's not a confession.
whatever it is we're dealing with. Oh, look at this. Are we doing this today? We're getting this far? We are. Okay, cool. So, Baron, your dreams come true. Woohoo. We have our same old function. Draw y equals negative f of x. Notice that negative is happening. Oh, outside of the protected axis, y. Y. You have three things that just know and y. So our y values are going to become opposite with whatever they were. I can't say negative. It's in here, exactly. Correct. Let me do the dashed hopes and dreams of our childhood. I mean the dashed function. So that -4 comma -1 comes -4 comma +1. Finish it off. Just the each one of the y values becomes opposite of what it used to be. So like we alluded to earlier, that's called a reflection about the, or with respect to the x-axis. If the negative is on the inside, it's not going to affect the y values, it's going to affect the x values. So that -4 comma -1 becomes 4 comma -1. I'm going to dot these in again. Optional, but recommended to do that every time you're doing a transformation. -4 comma -1 becomes 4 comma -1, etc. Let's get a little confusing with all that stuff there. Not a bad idea to use colored pencils. Thank you for those of you who brought one, or if you, it'll make your life a little easier. If you didn't bring it, I ain't mad at you. You have enough to deal with. But think about it. So it's resulted in what happened to the original function? Yep, so it's about the y-axis, otherwise known as. Instead of flipping, reflected over the y-axis, so with respect to the y-axis, or about the y-axis. So here's a little summary of it. If you want. Summary. Outside changes result in y differences. Inside changes result in x differences. And when I say difference, I don't mean in the form of subtraction. I just mean it's moves somehow. Okay. 5, would you please show me the parent function or the library function that you're going to use for number 5? Would you show me what this looks like right in front of you? I normally use my arm. It's hard to do with your hand, but this just doesn't work. But I do this one. Hey, go ahead and discuss with your neighbor what's going to happen to this parent function when you graph it. Say that again. Mm-mm. Okay, so the negative, would you please show me what the negative does in gestures? What is the negative going to do? Now it's inside, so it's affecting the x's. When it's inside, it's going to do this kind of thing, right? Reflect over the y-axis, and that +2 is going to move it up. We know it's up and not left to right because it is outside the function, right? I'm going to refer to that dozens of times each day. So this is reflect over y-axis, and this is up 2. I'm going to dash in my normal function. I hope that we're comfortable with this. Now we need to take each point and follow the direction. After you establish the personality, getting back to them. I'm going to dash this one. And you can take the points, and anytime that we know on the graph and follow the direction. That's this one, you're going to reflect it over y-axis, which the secondary and I'm going to use up to. So if I have anything, those guys again, I'm 10 times. I just put my right here. That's awesome. So for this one, my next point, you see where it's going to go? It goes here and then up 2. That's my second. I just do that for all points. Go ahead and do that for everything. Okay? You get these 3 points exactly. Okay, and you just connect them. It should look something like the other one. And you should be able to see the reflections and or shift as appropriate. Any questions? Okay, please discuss before, don't draw anything for number 6, but discuss what is gonna happen, like what's the parent function, what's gonna happen to it in number 6, please. Okay, show me the parent function. I could grab it, yeah, parent function. Okay, so we're just making it's gonna do the parent function. It's outside, it's going to get this, with 2, it's going to move it to the left. 2 units, and then the 4th and move it up. Now, you may ask, yeah, I'm okay with those things. Which one comes first? It matters. Now, and it comes from order of operations. Now, normally order of operations is this, right? PEMDAS. But for translation, there's no parentheses, there's no exponents for translation. So what we're left with is MDOS. So anything that involves multiplication and division comes first, then addition, subtraction. So it must be that order. Otherwise, you run the risk of reflecting something that's already that moved or that may be inappropriate.
Here's the thing, you reflect before you do anything.
Yes, in this case, we reflect first.
Okay.
Move. Reflect, move, move, reflect, move.
We're going to not calculate them.
Which is done, or stop checking with your neighbor. And want some help. Chloe, can you give me a hand with this, please? Okay, so you move that one first. Try like these real quick. Okay. And what'd you do with that -2, 4? Well, that's your final. Okay, where did that come from? Oh, so you're moving the vertex first. Oh, okay, I see. So 0, 0 stays there after reflection, and then. Okay, and then up 4, and just happen to be on the original parabola. Okay, so that's gonna be the vertex of our new one. Okay, nice. I'm gonna do this in red. Okay. There 1, 3. Okay. Do we agree? Are we good with these? Any questions? What's that? Well, on my original graph, I had 1, 2, 3, 4, 5, and on the translation or the transformation, there's also 5. And you could put in more if you like, but just whatever you had originally.
You don't want to.
Not at this point for these transformations, just whatever you start with, finish with them. You don't have to add anything else unless you feel compelled to. Thank you though for asking. And then from here, I imagine just connect them smoothly, make that upside down parabola. Thank you. Nicely done, Chloe. Any questions? Okay. Here is some practice for you. Oh, there's a whole bunch. Oh, look at all these fun problems you get to do. So lucky. If it doesn't fit, then you don't have to put it. I've been calling 4 people to come up and do these. The nice thing is that the graphs here are much bigger than the ones on your paper.
No, I think it's inside. So for that, it's inside. So it's like, it's inside. It's inside, so it's gonna be 2x, and that'll gonna be 1 word. Because otherwise it would be 1/2. If it was, if this is versus, it'd be 1/2. Instead of 1/2.
When these 4 people are ready, someone else will start dashing. If you could show me the dashed as well as the ultimate.
I just want to do one.
Yes. Oh, whatever you like.